Okay, so today we're going to talk a little bit more about volume. We've already learned how to find the volume of a prism. And when we spoke about volume of prisms, we had two different formulas. The first formula is volume is the length times the width times the height. So in a three-dimensional prism, we have a length, a width, and a height. What this is referring to, the width and the length and the width refer to the length and the width of the base. The base of this particular prism, because of the way I labeled it, is going to be this. This is the base, the length and the width of the base. And we multiply that by the height. And that's the height of the prism. The height of the prism is the distance between the two parallel bases. So if there's a base here, there's also a base back here. So the front and the back are going to be the bases of this prism. And then we multiply it by the height. Well, we've learned before that area is length times width. So the area of the base of a prism is length times width. So what we're actually doing is we're finding the volume equals B, which is the area of the base, B, times the height of the prism. See, the length and the width is the area of the base, and H is the height of the prism. So it's very important to understand what the B stands for. The B stands for the area of the base, this being the base, and in the case of a rectangular prism, the area is just the length times the width times the height of the prism, the height being the distance between the two bases. So we need to be able to relate this to other types of prisms. Going back to the volume equals the area of the base times the height. What if we look at a triangular prism? So a triangular prism has two bases that are triangles. Okay, so we have the triangular prism here. Here is the triangle. This is the base. This is also a base. This is the height of the prism. The height of the prism. Maybe I'll put a little P there to indicate that's the height of the prism. The B is the area of the triangle. So now we need to go back and we need to remember how to find the area of the triangle. Well, the area of the triangle is the base times the height. You could put over 2 or divided by 2, whatever works easiest. This H is not the height of the prism. This H is the height of the triangle. In this case, it would be the line that goes down. So let's take a look at an example with a triangular prism. So this gets plugged in for the base times height. So the volume, instead of having a big B times height, if you take the base of the triangle times its height, divide it by 2, and this is the height of the triangle, and multiply that by the height of the prism, this will get you the volume of a triangular prism. So volume equals the area of the base times the height. Here's our triangular prism. Okay, let's say the bottom of the triangular prism is 6. The prism's height is 8. The triangle's height and the prism's height is 10. Okay, so first I need to find big B, which is the area of the triangle. That's the triangle's base times the triangle's height divided by 2, which equals 6 times 8 divided by 2. So now we have 48 divided by 2, which is 24. So this goes back into the equation for the big B. So now our formula equals 24 times the height of the prism, which is 24 times 10, which is 240, and it would be measured in cubic units. Okay, so you see how we substituted in that 24 for the big B. Big B was 24. Okay, so now that we've had a chance to recall the volume of triangles and the volume of prisms, both rectangular and triangular, we need to look at one other shape. The good news is we can still keep that original formula, volume equals base times height, but we're going to apply it in a different way. So we're going to be learning about the volume of a cylinder. And the good news is it's done exactly the same way. However, we're going to be looking at it from a little bit different perspective. Okay, so now I have my cylinder. We have a round top, then it goes down, a round bottom. So this is our cylinder. Looks a lot like a soda can. The first thing we want to do is be able to identify the bases. Well, a cylinder has 2 circular bases. So here's a base, and here's the base. Okay, and what we remember from before, the height is still the distance between the bases. So that's the height of our prism cylinder. So our big B is the area of the base. Okay, so this time our base is what shape? It's a circle, right? So now the big B is pi r squared. The area of a circle is pi r squared. Okay, so let's plug in a number for h. Let's say that h is 10. Let's give ourselves a radius of 3. And that's all the information that we need. We need the height and we need the radius. The radius equals 3. Okay, so I need to find the volume of the base. So B equals pi. My radius is 3 times 3 squared, which is pi times 9. Okay, so if I do 9 times pi, I get 28.27. Okay, and I go back to my formula. Volume equals the area of the base, 28.27, times the height was 10. And if I multiply that out, I get 282.7 cubic units. Okay, so I'm doing the exact same thing. I'm finding the area of the base, and this time our base is round instead of a triangle or a rectangle, and that's okay. So instead of using the formula for a triangle or a rectangle, we're using pi r squared. Okay, so the volume of a cylinder is still big B times h, but now big B represents the area of a circle instead of the area of a triangle. Let's look at some examples. Okay, so the first example, we have this cylinder. And the first thing I'm going to do is say, well, I know I have a cylinder. So this is my base. And this is my base. And my height is the 7 centimeters. So I have volume equals the area of the base times the height. The area of my base is pi r squared. My base is pi times 3 squared, which is 9 times pi, which was 28.27. Okay, now I go back to the original formula and I plug in 28.27 for B. So volume equals 28.27 times the height of the cylinder. In this case, it's 7. And now I get a volume of 197.92. So you see, I had my original formula, volume equals base times height. Then I found my volume, my base. I plugged my base into the original formula. So that was the base, that's the height. And then I got my value here, and that should be cubic centimeters. Okay, 197.92 cubic centimeters. Okay, we'll look at another example. Okay, so I have another cylinder. I'm going to shade my base. So once again, volume equals base times height. The big B is the area of the base, so I'm finding the area of the circle. This time they're trying to trick me, and I'm not going to fall for it. They gave me the diameter of being 8 millimeters. So if my diameter is 8, then the radius is 4. Okay, I'm going to use the 4 in that formula. Okay, so my base is pi r squared, which is pi times 4 squared. Okay, so now I'm going to come in, I'm going to do 16 times pi, and that gives me 50.27-ish. And then I'm going to plug that in. So now I have volume equals 50.27 times the height, in this case is 3, and I'm going to multiply times 3. Now my volume is 150.8 cubic millimeters. So you can see I color-coded it so you can see what we're substituting in. So we have our base was equal to 50.27 pi r squared, and then we were able to get our volume by doing that substitution. Let's look at another one. Okay, we've got another cylinder. Volume equals base times height. I need to find my base. Again, our base is a circle because we're dealing with a cylinder. So we have pi r squared. This time they're not trying to trick us. Our radius is 3. So now we have base equals pi times 3 squared, which is 9 times pi, which is 28.27 again. So our volume is equal to 28.27 times the height of the prism, which is 8. And now we get 226.19 cubic kilometers. Okay, now it's time for you to try. Here are 2 for you to work out. Find the volume of this cylinder, and then determine how much soda you can fit in this can. Go ahead and pause it, work it out. The answers to the you try will be posted on my website.